So we talked about structural isomers, and now we need to talk about geometric isomers. We did touch upon geometric isomers once upon a time earlier in the school year, and I think that we need to kind of continue our conversation about that. So, that's trans. Now, geometric isomers occur when a molecule is a double bond. The double bond locks the atoms into a fixed position and limits the rotation around the bond. We know that the double bond is shorter than the single bond. We know the double bond is stronger than the single bond. But what it allows in organic chemistry is the ability to create two distinct possible molecules that can have the exact same formula, but be connected in the same way, like a structural isomer. But those two different things, those two different orientations, are cis or trans. Cis isomers are ones where the substituents or the branches are on the same side of the double bond, and trans are isomers where the substituents or the branches are on opposite sides of the double bond. So below I have double bond here, here, and so that's telling me that it's an alkene. The longest continuous chain of carbons in both of these is 1, 2, 3, 4, or 1, 2, 3, 4, and as a result of that, the name or the prefix we would use is for 4 carbons long, which would be a bute, not a but it'd be a bute, 4 carbons. And then the 2 in this case, because if we're gonna count, it would be 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3, 4. So the 2 is essentially telling us where the double bond is located. In this case, it's between the second and third carbon, no matter which way we number it. Now, the term cis or trans in this case is telling us whether or not the substituents or the branches are on the same side, cis means same side, or opposite side, trans means opposite side of the double bond. So we'll walk through a couple of these together. So how to name a cis molecule. In this particular structure up above, there's a lot of things I'm going to kind of walk through the naming as it's written here, but I'm just going to talk about it. So the first thing that I look at is I identify that there is a double bond present, and that double bond is located right here. So I know that it's going to be an alkene with a double bond. The next thing I'm going to look for is the longest continuous chain of carbons. So 1, 2, 3, 4 is the longest continuous chain of carbons. So I know the prefix has to be a 4 carbon long prefix, which is the bute prefix. And we should number the chain. So 1, 2, 3, 4, or 1, 2, 3, 4. It appears that the double bond occurs between the second and third carbon, no matter how we write it. So I'm going to call it a 2-butene. Now, there are 2 branches. In this case, the branches are Cl branches, and those we're going to learn about in the next lecture, and they are called they're called functional groups. So we'll talk about that for a second. They're functional groups, and these are a special class of functional groups that we call alkyl halides, because they're halogens. So how alkyl halides are named is essentially we drop their elemental ending, chlorine, and we just kind of call it a chloro or a fluoro or a bromo, or in the case of iodine, an iodo. So these are chloral groups. And there's 2 of them, so we should probably tell the world where those are located. But in any case, in terms of adding them, we have to identify a couple of things. So the first thing is we have to figure out where the chloral groups are. So because they're functional groups, I'm going to call them CHLORO. And because there's 2 of the same, I'm going to call it dichloral. There is a lot of redundancy in organic chemistry, And because we have to tell the world where they're located on the chain, we're going to say it is a 2,3-dichloryl 2-butene. Now the last thing that we have to go ahead and add is we have to identify whether it's cis or trans, and because they appear to be on the same side of the double bond, we're going to call it cis 2,3-dichloryl 2-butene. Here's another molecule that we call that is a very, very similar molecule. As a matter of fact, it's the exact same, but we're going to walk through the same process and identify it differently. So again, the first thing that I'm going to notice here is that there's a double bond, so I know that's going to be an alkene. I'm going to now look for the longest continuous chain of carbons, 1, 2, 3, 4, and in this case, it's a 4-carbon long alkene, so it's a bute. And we have to tell the world where the double bond is located, so I'm going to count 1, 2, 3, 4, 1, 2, 3, 4. So the carbon appears to fall between the second and the third carbon, so I'm going to call it a 2-butene. And then there are, in this case, there are some functional groups. There is the, again, we're going to call it the acyl halide. So it's a functional group, and because it's an acyl halide and it's the same, it's a chloral again. And there's 2 of them, so we're going to call it a dichloral. So chloral, and there's 2 of the same functional group, so it's a dichloral. They happen to appear on the second and third carbon, so it's a 2, 3. And this time, their orientation around the double bond happens to be opposite sides, and because it's opposite sides, we call it trans. So it's trans 2,3-dichloryl 2-butene. When we have to draw the structures, we do the same thing that we've been doing in the past, which is kind of deconstructing the name. And so in the case of the first one, I see that there's an ENE ending, which tells me there's a double bond. The eth tells me it's 2 carbons long. The chloral tells me it's a chlorine, and the di tells me there's 2 of them. The 1 and the 2 tells me the location of that, and the cis tells me the orientation around the double bond. So in this case, I'm going to start by drawing my structure. So I have 2 carbon long, double bonded chain. I now also see that I can number them however I want because it's my chain, so 1, 2. I see that there are 2 branches, and those 2 branches are going to be located around the double bond because it's a 1, 2. They're chlorals, so I'm going to put a Cl here and a Cl here, and I'm doing it on the same side because it's cis. Now all that's left to do is I have to go back and make sure that each carbon has 4 bonds, and we add hydrogen to make sure that each carbon does. So the number 1 carbon has 3 bonds, so I'm going to add a hydrogen here, and the number 2 carbon has 3 bonds, so I'm going to add a hydrogen here. So that would be cis 1,2-dichloroethene. The other one we can practice is this one here, which says trans 1,2-dichloroethene. So the ene tells me it's 2 carbons long, or ene tells me it's a double bond. The eth tells me it's a 2 carbon long chain. The chloral tells me it's an acyl halide functional group. The di tells me that there's 2 of them, and the 1 and the 2 tells me the location of the chlorines. Now trans, in this instance, is going to tell me that they are opposite sides of the double bond. So what I'm going to do is I'm going to start drawing the structure. So I'm going to draw the 2 carbons. I'm going to double bond them together. I'm going to take one of the chlorines and put it on one side, and the other chlorine and put it on the other side. And so I've put it in the trans orientation. And now the last thing I have to do is I have to go ahead and identify where, or if my carbons need any more bonds. And so in this case, I've got 1, 2, 3 bonds on the number 1 carbon. So I'm going to add a hydrogen. And on the second carbon, it's got 1, 2, 3 bonds, so I'm going to add a hydrogen. And now I have trans 1,2-dichloroethene. again, after watching this video and doing some practice, if you have any questions, shoot me an email or send me a message through Classroom and we'll figure it out.